Good evening, all of you. So this is the session 6. I welcome you all in the session 6. So let's start the first question. So this is the GATE 2021 question number 13 that came in set 1. So the question is the liquid form of particulate air pollutants are. They have given four options: dust and mist, uh, mist and spray, smoke and spray. So they have given four options. That is, first one is dust and mist and spray, smoke and spray, fly ash and fumes. So we will discuss about the major classes of particulate air pollutants. Then we will solve this question. So basically, the major classes, major classes. This is next is subclasses. Another row will be a typical member. Typical member of subclass. The major classes first comes particulate. Particulate. Subclasses comes solid and liquid. In solid, dust, smoke, fumes, and fly ash comes under the solid subclasses. In case of liquid, mist and spray. So first under first particulate, there are two subclasses, solid and liquid, and under those the member comes. So second subclass involves organics. Under organics, one is gaseous hydrocarbon, gaseous hydrocarbon first. Second is aldehyde and ketone. Third is other organics. Now in gaseous hydrocarbon, basically comes hexane, benzene, ethylene, and methane. Aldehyde under aldehyde and ketone, formaldehyde and acetone come. And under other organics, alcohol, chlorinated hydrocarbon. So basically, these are the uh, I think few more people joined, so I will briefly again explain. So in GATE 2021, this was the question: the liquid form of particulate air pollutants are. They have given four options: dust and mist and spray, smoke and spray, fly ash and fumes. So we will first look at the specific major classes. Then we will go discuss about the correct answer. Under the major classes, one is particulate and organic. The third one is inorganic. So this is particulate. Under particulate, subclasses are solid and liquid. Under solid, dust, smoke, fumes, and fly ash are the specific members under of subclass. Under liquids, mist and spray. So in similarly in organics, subclasses are gaseous hydrocarbon, aldehyde ketone, and other organics. So the members to the respective subclasses are I have mentioned here. Now the third subclass. Now coming back to the third one. So above I have mentioned the two. Third is inorganic. Inorganic. Under inorganic, oxides of carbon, Oxides of sulfur and oxides of nitrogen are the under oxides of carbon CO, CO2, under sulfur SO2 and SO3, under the oxides of nitrogen NO2 and N. Now we know that the three major classes exist. One is particulate matter, second is organics, third is inorganic. Now let's come back to the question. So the liquid form, they have mentioned the liquid form of the particulate air pollutant are. So we will go back to the table. Here under the liquid, the two mist and spray are the specific members under the subclasses of liquid. So the correct answer is mist and spray. Option number B is the correct. Just a second. I think I am unable to write actually. So the so mist and spray are basically the correct answer. So option number B is correct. Mist and spray. I hope it is clear. So is there any doubt?
No, sir.
Okay. Now so moving forward, the this is the question number second. This question came in 2020 in set 1. So in this question they mentioning a stream with a flow rate of 5 metric cube per second have an ultimate VOD of 30 milligram per liter. A wastewater discharge of 0.2 metric cube per second having POD 5 of 500 milligram per liter joins the stream at a location and gets mixed up instantaneously. The cross-sectional area of stream is 40 meters square, which remains constant. The BOD exertion rate constant is 0.3 per day, logarithm base to E. So they have mentioned base to E. The BOD remaining at 3 km downstream from the mixing location is. Okay. Now we will go start with the basic concept basically. So we know that the graph of amount of oxygen equivalent of organic matter with time t is this one. So this basically is the initial organic matter L naught. So the basic, so I will draw it properly. So this is time. X-axis denotes the time, and this is the in y-axis is the amount of oxygen equivalent of organic matter L naught. This we term as L naught starting from here. Now LT basically means LT. L naught is the amount of organic matter present at time t is equals to 0. LT is the amount of organic matter present at time t, present at time t. Okay. Now knowing this, so if I have to write this graph in terms of equation, how I will write? So obviously I will write dLt by dt is equals to minus of KLT. So K is basically the reaction constant minus because it is decreasing with time. I hope it is clear. Since we are differentiating with respect to time, so with time it is decreasing, so it is minus. So basically dLt by dt is equals to minus KLT, LT is the LT basically means here LT is the amount of organic matter at time t. At time t. Okay. Now if we solve this equation, dl by dt by lt is equals to minus of k dt. So from lt of this I send it to the denominator. From dt I have kept it here. So from if we integrate it with, we will integrate from L naught because that is the initial organic matter at time t, and LT is organic matter at time t with 0 to t integration. So we will get log t, log with base to e, LT minus log base e L naught is equals to kt plus c. So kt plus c, since, so next slide we will move. So at t is equals to 0, we know L is equals to L naught. So L to L naught, if we do L naught, okay. So this we got. So log E. So we know because that t is equals to 0. So L is equal, at t is equals to t, LT is equals to LT. So C will become 0. So here at t is equals to 0, L is equals to L naught. We knew that. So since if we write in this form as log E LT by L naught is equals to K t minus 0, because 0 to t, if we differentiate t minus 0 and log e, can we write it, we can write this equation as log a upon b, because we know log a by b is equals to log a minus log b. Okay, now moving forward, so if we do it, LT will become is equals to L naught e raised to minus kt. If we have to write this equation, LT by L naught is equals to e raised to minus kt. So if LT will go at this, then it will become LT is equals to L naught e raised to minus kt. Okay. So this is the BOD at time t. BOD, if someone asks, the question asks BOD exerted during the time t, BOD exerted, then we have to do L naught minus LT. So that time our formula will become E minus kt is equals to L naught 1 raised to E minus kt. I hope till here it is clear. Is it clear?
Yes, sir.
Okay. Now, since the question, so there is a trick in this question. They are asking the BOD remaining. The BOD remaining at 3 kilometer downstream from. So basically, they are asking BOD at time t. If they would have asked us BOD exerted, then we would have applied this formula. So now coming back to the question. So this was the concept till now. So beginning with the question, a stream with a flow rate of 5 meter cube per second having ultimate BOD. So suppose this is a stream. So flow rate is 5 meter cube per second. Ultimate BOD is 30 milligram per liter. Okay. A wastewater discharge of 0.2 meter cube having BOD 500 will join the stream. So some wastewater is joining the stream here. Now this is the wastewater. So the question wastewater discharge flow rate is 0.2 meter cube per second and BOD 500 milligram per liter. So everything they have mentioned. First, now see, to know the how to approach this question. To know the BOD of the mix, to know the BOD of the mix, we have to calculate the ultimate BOD of the wastewater, because the stream which is flowing, they have the ultimate BOD they have mentioned for the stream. So see, here they have mentioned the ultimate BOD. However, for wastewater which is discharged in the stream, they have mentioned the BOD 5. So therefore, we first have to calculate the ultimate BOD of the wastewater discharge. Then we will calculate the BOD of the mix. So now, to calculate the for wastewater, we just now have derived this LT is equals to L naught. They have mentioned BOD at for 5 day. 5 day BOD 500 milligram per liter. So 500 L naught 1 minus e raised to. So rate constant they have mentioned 0.3 per day, that to base to e. So 0.3 and into 5. Since the BOD is of 5 days, so time taken is 5 days. From here we can calculate the L naught into 5. This is minus. So L naught will come out to be 643.60 milligram per liter. So L naught basically here means the ultimate BOD of wastewater. Ultimate BOD of wastewater. Knowing the ultimate BOD of wastewater, now we can calculate the BOD mix. So BOD ultimate of mix. BOD ultimate of mix. Here mix means the point where both the wastewater are merging. So this point. So BOD mix means here at this point I will be calculating the BOD of mix. So BOD of mix means BOD U of wastewater into discharge plus BOD U of stream into discharge Q1 Q2 upon Q1 plus Q2. So this was for wastewater and this will be for stream. So just now we have calculated the ultimate BOD, which came out to be 643.60. This 643.60. The discharge flow rate was, let's go back to the question, 0.2 meter cube per second. 0.2 plus the ultimate BOD they have mentioned for stream is 30 milligram and with a flow rate of 5 meter cube per second. So basically 30 into 5 divided by 0.2 plus 5. So which will come out to be 53.60 milligram per liter. Okay, now we know the BOD ultimate of mix is 53.60 milligram per liter. Now the further steps are, so in that question they haven't asked about the BOD at the point of merging. They have asked the BOD remaining at 3 kilometer downstream from the mixing edge. So so this is the mixing location. This is the mixing edge. So 3 kilometer from here to there, 3 kilometer. What will be the BOD remaining? So so time. So for a water to flow 3 kilometer, let time taken to travel 3 kilometer is t. Okay, so distance is equals to speed into time. That is very basic, we know. So time will be Distance by speed. This is the basic formula in math. We know that to calculate the speed basically here means the velocity. So velocity is equals to Q by A. Discharge by area, we know the velocity. So Q total mix. So water which will go, how to calculate the Q discharge? So the water which will go at the downstream, that will be the Q1 and Q2 of both the wastewater and stream. So the total discharge will be Q1 plus Q2, which will come out to be uh, 0 0.2 and 5. So that is 5.2. 5 plus 0 0.2, and area in question they have mentioned area as 40. So in question they have mentioned the cross sectional area of the stream is 40 meter square. Okay, so divided by 40 we will get the velocity. So if we divide, so just a second, the pen is not there. So if we divide 5 plus 0 0.2 by 40, we will get as 0.13 meter per second. Just give me time, I will restart this. Just a second. So now we will add this 50 plus 40, we will get 0.13 meter per second. So now we have the speed, we have the velocity. So for time we can calculate easily. So time is equals to distance upon velocity. So distance comes out to be 3000 divided by 0 0.3. Just now we calculated, it will come out to be, since it is in meter, and time is in meter per, velocity is in meter per second. So the value will come out to be 23076.92 seconds. If you convert it into day, it will come out to be 0.267 days. So now the question is, therefore BOD remaining BOD remaining after 3 kilometer, or 0.267 days is equals to VOD T is equals to L naught e raised to minus KT. Since they have asked about the remaining, so BOD T is with L naught e raised to minus KT. So L naught will be 53.60, which we have calculated from the BOD mix, that is the L naught into E raised to minus, in question they have already mentioned us K value 0.3 into time we have already calculated 0.267. So the answer will come out to be 49.5 milligram per liter. 49.5 milligram per liter. Is this is clear? Do someone has any doubt? Okay, I will explain once again the entire concept, then we will move forward. So in the question they are telling us the one wastewater and the stream. The wastewater is joining the stream. So after joining the stream, what will be the BOD remaining at 3 kilometers downstream from the mixing location? So, so wastewater, the flow rate they have mentioned, the BOD 5 of flow wastewater they have mentioned as 500 milligram per liter, and for stream also they have mentioned the flow rate 5 metric cube per second and the BOD discharge 30 milligram per liter. Now, at first, the approach should be to calculate the BOD ultimate BOD of the wastewater, because for stream they have mentioned as ultimate BOD. This was the ultimate BOD they have mentioned. However, for wastewater, they have mentioned the BOD 5. First, we will calculate the ultimate BOD of wastewater. Using that ultimate BOD, we will calculate the BOD ultimate at the mixing location. So here I first derived how to what will the formula of ultimate BOD. So these all things I have mentioned. So beginning with this, for wastewater, we first calculate, this was the first step. We calculated the ultimate BOD of the wastewater. From this ultimate BOD, we calculate the ultimate BOD of mix, that is at the mixing point. This is the second step. After calculating the ultimate BOD of mix, since the question is asking me the remaining BOD at certain distance from the mixing point, I calculated let the time travel taken by water to travel 3 kilometers t, distance is equal to speed into time. So velocity from basically, if it is good if we calculate, tell it as a velocity, that will be more accurate. Velocity and distance, speed by velocity. So distance by velocity, velocity is equals to q by a, we know. Q discharge, we took 5 plus 0.2 because in the downstream both the water, wastewater and the stream will, after merging they are going in downstream. So basically, if this is the wastewater and this is the stream flowing, they have asked us about this point. So after seeing Q1 and Q2 will both mix, so here it will be Q1 plus Q2. So that's why total flow will be 5 plus 0.2. Area they have mentioned in the question 40. From here the flow velocity of the stream is 0.13 meter per second. After calculating the velocity, we calculated the time. So this was the third step. Then we calculated the time, that is the fourth step. After calculating the time, we calculated the BOD remaining after 3 kilometers. If they would have asked us about the BOD exerted, then we would have used this formula L naught minus LT, which is equals to L naught 1 minus E over KT. I hope it is clear. If anyone of you has any doubt, you can ask. Do anyone has
Clear,
any?
sir.
Okay. Others are also clear. Okay. So, moving back to the next question, which one of the following is secondary pollutant? So, first, about secondary pollutant that they have asked, they have given first option as ozone, carbon, second carbon monoxide, third hydrocarbon, and fourth is volatile organic carbon. So, before solving this question, we should first know what is secondary pollutant and what are the other pollutants based on the classification. So, air pollutants. If we talk about air pollutants are categorized into primary pollutant and secondary pollutant. Primary pollutants are those that are directly emitted from the identifiable sources. So basically, primary air pollutants, primary air pollutants are those which are emitted Primary air pollutants are those which are emitted directly from identifiable sources. Directly from identifiable sources. So this is the one thing. So primary air pollutants are those which are emitted directly from the identifiable sources. Now comes secondary air pollutant. Secondary air pollutant are those secondary secondary air pollutant are those which are produced in the air, which are produced in the air by the interaction by the interaction uh, among by the interaction by the interaction among two or more primary pollutants. Two or more primary pollutants, or by reaction with or by reaction with normal atmospheric constituents, normal atmospheric constituents with or without photoactivation. With or without photoactivation. Photoactivation is basically energy from sunlight. It basically means energy from sunlight. So air pollutant basically is divided into two: primary pollutant and secondary pollutant. Primary pollutant are those which are emitted directly from identifiable sources. However, secondary air pollutant are those which are produced in the air by the interaction among two or more primary pollutants, or by reaction with normal atmospheric constituents with or without photoactivation. Okay. Now, what are the examples of primary pollutant and secondary pollutant? This was the one point. So this is the example of primary pollutant which I will write now. It is, first is finer particles, uh, finer particles. Second is coarse particles. Third is sulfur compounds. Second is oxides of nitrogen. Oxides of nitrogen. Carbon monoxide. Organic compound. Organic compound. Okay. So all these are, and this one is 6. So all these are the examples of primary pollutant. However, for secondary pollutant, the examples are ozone. Second is formaldehyde. Third is PAN, which we known as peroxyacetyl nitrate. Fourth is photochemical smog. Okay, and fifth is basically Formation of mist. Formation of mist, acid mist basically, not only mist, as formation of acid mist H2SO4 due to the reaction of. Okay, I will write this fifth point in the next slide. So fifth point under the fifth class under the secondary pollutant is formation of acid mist. Formation of acid mist H2SO4 due to reaction of sulfur dioxide and dissolved oxygen. When water droplets are present in the atmosphere. I hope it is clear now. So primary air pollutants are categorized into two. One is primary and secondary. Under primary pollutant, the examples are finer particles, coarse particles, sulfur compound, oxides of nitrogen, carbon monoxide, organic compound. Under the secondary pollutant, ozone, formaldehyde, pan, photochemical smoke, formation of acid mist due to the reaction of sulfur dioxide and dissolved oxygen when water droplets are present in the atmosphere. This was the fifth point under the secondary pollutant. Now let's go back to the question. Which was the following the secondary pollutant? So just now I have given the examples, and based on the examples, so here ozone is the secondary pollutant. So option A is correct. The basic purpose of providing this much information is tomorrow instead of ozone they might give you as photochemical smoke or peroxyacetylene nitrate and formaldehyde. So that time you should be able to recognize the secondary pollutant. I hope this is clear. So is it clear?
Yes, sir. Clear.
Okay. Now we will move forward to the next question. So the next question, the a completely mixed dilute suspension of sand particles having diameter 0.25, 0.35, 0.40, 0.45. So they are basically provided the diameter of particles. So beginning with 0.25 mm, then 0.35 mm, 0.40 mm, 0.45 mm, and 0.50 mm. So diameter of particles are filled. They are filled in a transparent glass column. They are filled in a transparent glass column. Basically, column. They are filled in a transparent glass column of diameter 10 centimeter and height 2.5. The suspension is allowed to settle without any disturbance. It is observed that all particles of diameter 0.35 mm settle to the bottom of the column in 30 seconds. For the same period of 30 seconds, the particle removal of for the percentage removal of particles of diameter 45 and 50 mm from the suspension is okay. Now we will start with basics, then we will start the settling. So this is the since they are telling about the settling, they have mentioned suspension is allowed to settle. So this is the question of settling velocity concept. So settling velocity for discrete particle is equals to gs minus 1 g d square upon 18 mu. I have already mentioned all these formulas in the previous videos. I will advise you to you can go through those videos from the YouTube. So Vt is equals to Gs minus 1 d g d square, where mu is the kinematic viscosity in this expression. Okay, and d is the diameter of the particle size basically. B is the particle size. Now For different particles of same density, a particle with higher diameter will settle down faster because in this expression Vt is directly proportional to the d square. So based on this expression, we can say that settling velocity is directly proportional to the diameter of the particle square. So for different particles of same density, so therefore this line is important. Therefore, for different particles, for different particles of same density, a particle with a higher diameter will settle down faster. Therefore, so based on this equation, we can write therefore for different particles of same density. So same density I am talking. A particle with high diameter will settle down faster. So for 30-second duration, so based on the question, for 30-second duration, if 0.35 mm particle settles completely, if 0.35, so basically for 30 seconds, if 0.35 mm particle settles completely, then it is obvious that particle greater than this size, that is 0.45 0.40 mm, 0.45 mm and 0.50 mm will settle completely because terminal velocity settling velocity is directly proportional to d square. If this particle is settling in 30 seconds, the diameter of the particle, which is greater than this size, will obviously will also get settled completely. That means it will be 100% removed. So based on the question, since they are telling for the same time period, the percentage removal of 0.45 and 0.50 mm particle suspension is, so it will be percentage removal will be 100% because we know we now know that the Vt, the settling velocity, is directly proportional to d square. Since the diameter of the particle which they have mentioned in here, that is 0.45 and 0.5 mm, are greater than that of the 0.35 mm. So if 0.35 mm particles are settling completely in 30 seconds, that means obviously the particles with having size greater than 0.35 mm will settle down completely. So that's why 0.45 and 0.50 mm will settle 100%. So the answer will be the percentage removal of particles of diameter 0.45 and 0.50 mm from suspension is 100%. This is percentage. So is it clear? Do anyone of you has any doubt till now whatever I have discussed? So if anyone has any doubt, you can text.
Sir, can you explain about different types of loading rates?
Okay, different types of, it depends upon the different types of in this question they are not talking about loading rate.
Y-
Hello.
Yes, sir, I had different doubt actually.
Okay. Yeah. Okay. Go ahead. Hello, Srijan. You are telling something.
Hello.
Yes. You want to tell.
Sir, I had doubt from. Yes, sir.
You.
If you could explain a bit about loading rates, sir. I had a doubt from wastewater engineering, not
Okay.
specific to this the questions that you have discussed.
Okay. Like what is meant by organic loading rate? You want to ask about the organic loading rate, right? OLR.
Yes, sir. Organic loading rate and then hydraulic loading rate, surface
Okay,
loading rate. I want to know the difference between all of them.
okay. So, Sejan, uh, in next class, I will cover this organic loading rate and hydraulic loading rate. However, I have already discussed all those things in the while discussing for activated sludge process. So, if it is possible for you, you can go back and read those lectures. However, I will again discuss those in upcoming lectures. Okay,
Okay, sir. Okay, sir. So I
because
will
right
watch
now
the
we are
lectures once.
focusing on different concepts, right? Certainly, I cannot discuss about this. So, next class, I will surely discuss about organic loading rate, hydraulic loading rate. Okay, what is meant by hydraulic retention time. Okay, so
Okay. Yes, sir. Yes,
but
sir. Yes.
but I will advise you just you can go back and look the previous lectures. Okay,
Okay. Yes, sir. Yes. Okay, sir.
okay,
Thank you, sir.
yeah, well, but surely I will discuss these things again in the next class. Okay.
Yes.
Okay. So the next question is the chlorine is used as the disinfectant in a municipal wastewater treatment plant. It achieves 50% of disinfection efficiency measured in terms of killing the indicator organisms E. coli in 3 minutes. The minimum time required to achieve 99% disinfection efficiency would be 9.93 minutes. So they have given four different options. So in that they are telling that the chlorine achieve 50% of disinfection efficiency measured in terms of killing the indicator in 3 minutes. So what will be the minimum time required to achieve 99% efficiency? So during disinfection, so the concept here, we will start the concept. So during disinfection variations in microorganisms is given by this equation. Nt is equals to n naught e raised to minus kt. Okay, so n naught here means number of microorganisms at time t. N naught means number of microorganisms at time t is equals to 0. Okay, so knowing this, so disinfection efficiency, if this is the number of microgram time t and this is the number of microgram time t is equal to 0, the disinfection efficiency is given by n naught minus nt divided by nt into 100. So that is the disinfection efficiency de. So I will denote it by de. Disinfection efficiency n naught minus nt into 100. So if we again expand this, basically n naught minus n naught e raised to minus kt divided by n naught into 100. Can we write it like that? Because see, disinfection efficiency is n naught minus nt upon n naught nt. Sorry, this is n naught. Hmm. So this nt can be, we can replace this equation nt is equals to n naught. So after replacing this nt here, so the expression will come out like this: n naught minus n naught e raised to minus kt upon n naught. So disinfection efficiency in question they are talking about the third day, 3 minutes. In 3 minutes. So basically efficiency at 3 minutes is equals to n naught minus n naught e raised to power, so 3k, k into 3, that will be 3k, because time they have mentioned as 3 minutes, into 100 is equals to, they have given 50%. So they have given a 50%. So if you solve this equation, n naught, if you take n naught common, 1 minus e raised to minus 3k upon n naught is equals to 0.5. N naught will get cancelled. E raised to minus 3k will come out to be 1 minus 0.5, which is equals to 0.5. If you calculate it, the k will come out to be 0.231 per minute inverse. 0.1231. So in next slide I will write. So after solving this, k will comes out to be 0.231 minute inverse, because time is given in minute, so the unit will be minute inverse. But in the question, they have asked that what will be the minimum time for the 99% disinfection efficiency. So for 99% efficiency, we will again use the same formula. Nt is equals to n naught minus nt upon n naught into 100. But for this time 99% efficiency. Now n naught we can again replace by kt. K, now we know the value of k, 0.231. 0.231 into t divided by n naught is equal to 0.99. So if you again solve it to the same way, so we can get the t value to be, so only t is the variable and this will get cancelled. So t will come out to be 19.93 minutes. Okay. So is this question is clear?
Yes, sir.
Okay. So again I will just explain. So they are telling initially that for 50% of disinfection it is taking 3 minutes. So what will be the minimum time that for 99% disinfection efficiency? So using the given data, that is 50% of efficiency in 3 minutes, we calculated the k value. After knowing the k value, we calculated the minimum time. So here, initially when we use the disinfection efficiency formula, we calculated the k value, that is k 0.231. After knowing the k value, when we are replacing it in the actual formula, so we are calculating the t value. So this we calculated from the given data. Knowing if we calculate from the given data, after knowing the k value, we calculated the t value for the 99% disinfection efficiency. Okay, so this was the summary of the question. Now next question. So a wastewater treatment plant treats 6,000 meter cube of water per day. As a part of treatment process, discrete particles are required to be settled in a clarifier. A column test indicates that an overflow rate of 1.5 meter per hour would produce the desired number of particles settling in the clarifier having depth as 3 meter. The volume of required clarifier would be. So first they have given the, based on the given data, Q discharge they have given as 6,000 meter cube per day. Okay. Now they are telling a, as a part of treatment process, discrete particles are required to settle in a clarifier. A column test indicates overflow rate of overflow rate of 1.5 meter per hour would produce the desired removal. Okay, overflow rate they have mentioned as 1.5 meter per hour. Okay. Now, so volume they are asking, they have mentioned given the value of depth. Okay, we know based on about the previous sessions, now you might be knowing that overflow rate is equals to Q upon area. Okay, since overflow rate is equals to Q upon area, Q is discharge, this is discharge. So area we can calculate by Q upon overflow rate. This is if for area, since we know the overflow rate, so this can go here, this can, so we can write the expression like this: overflow rate Q value they have mentioned as 6000 meter cube per day. 6000 meter cube per day. Overflow rate they have mentioned 1.5 meter per hour. 1.5 meter per hour. So the both the units are different, so we have to convert the unit 6000. So 1.5, if we multiply it with 24, then it will become meter per day. Here also it will be meter cube per day. Okay. So after solving this, we will get the area as 166.66 meter square. Okay. After cancelling the units, meter cube will get cancelled by meter. So now we know the area to be 166.66 meter square. To know the volume, we know volume is equal to area into depth. Area will come out to be 166.66. Depth given in the question is 3 meter. So answer would be 500 meter cube. So always whenever you are calculating, subtracting, dividing, look at the units. So they have mentioned in meter cube per day, it will be meter per hour. So you have to make a common unit, then you have to proceed further. So volume of tank, volume of the required clarifier will be, volume of required clarifier is 500 meter cube per day. So in this question, they have mentioned the discharge value. Okay, they have mentioned the overflow rate. Now they are asking that the particular overflow rate would, this overflow rate is sufficient for the desired removal of particle. They have mentioned the depth, so they are asking what is the volume of the required clarifier. Using the given data, we calculated the area of the clarifier. After calculating the area of clarifier, we calculated the volume of the tank. So area into depth, we came up to the volume of the required clarifier. So is this clear? Anyone has any other doubts?
No, sir.
Okay. So this was the last session. Last in the sense, this is the last question. So in the next week, I will clear your doubts, Srijan, regarding the HLR, hydraulic loading rate, organic loading rate. Okay.
Yes. Okay, sir.
Okay. So if you have any questions, you can ask. Else, you can. This session is over.